Batteries are everywhere, whether in our laptops or mobile phones, children's toys, heart pacemakers, or electric cars. These small portable devices provide us with all the power we need on the go. And although we may know that batteries are an essence of our everyday life, have you ever wondered how batteries themselves get made? To understand the journey of a battery during manufacturing, we must first look at the principle behind its working. Batteries produce power through a chemical reaction. The key to this reaction is moving electrons. Electrons are the negatively charged particles of atoms, and when they move, they generate power. This is accomplished by using two metals, or electrodes, that meet two critical criteria. First, they must be capable of conducting electricity, and second, they must be different metals. Why are there two different metals? Because one of them, the cathode, is always more electronegative than the other, the anode. In other words, it will be more effective at attracting electrons. In a battery, the plus sign represents the cathode and the minus sign represents the anode. The battle begins when these metals are connected in a circuit. Both will try to attract electrons to themselves. The cathode will always triumph and attract electrons from the anode. This causes electrons to move, and moving electrons produce electricity. A battery is a nearly complete but not quite complete circuit. The metals inside a battery are connected by an electrolyte, a substance that conducts electricity. But that's only a part of the story. When the battery is connected to whatever item it is supposed to power via what is known as the outer circuit, the circuit is closed. There is one more consideration for battery power. The anode will generate positive ions in addition to electrons. These travel through the electrolyte to the anode, while the electrons travel through the outer circuit to the item being powered. The electrons reunite with the ions from the electrolyte as part of the circuit closure. Another factor important to manufacturing of batteries is their type. Different batteries are made in different ways. We'll look at some of the most common batteries used today, as well as how car batteries and alkaline batteries are made. Lithium-ion batteries power electric vehicles. These are one of the most common rechargeable battery types and are commonly referred to as lithium batteries. If you have a device with a charger, it most likely has a lithium battery. When the battery is plugged into the power source, the chemical reaction that produces power is reversed, allowing electricity to flow into the battery rather than out, replenishing its power. These batteries' manufacturing process is complex and highly automated, but it can be divided into three main stages. 1. Producing electrodes. It all starts with an assembly line, a sizable one. The anode, which is usually graphite or zinc, and the cathode, which is usually some form of lithium oxide, are mixed with a conductive binder or electrolyte to form a slurry. The electrolyte in question for lithium batteries is typically a lithium salt solution. The anode is then wrapped in copper and the cathode in aluminum foil before being baked. 2. Cell formation. At this point, the anodes and cathodes have been kept separate to avoid cross-contamination. The electrolyte was kept under vacuum to prevent it from reacting with oxygen. But now, inside a case, all three are wound together with copper and aluminum wires. This is the cell that will be charged and tested. 3. Building the battery. A number of cells are welded to plates on both the anode and cathode sides of the battery. The number of cells required in each case is determined by the amount of electricity, or amp hours, required. The cells are then linked to a safety device called a battery management system. This keeps track of the battery power, current, and temperature. Finally, all of these components are placed inside a protective case, which is typically made of rubber, silicone, or plastic, and the entire battery is tested once more. And there you have it, a fully functional lithium-ion battery. Now, traditional automobiles use lead-acid batteries. Their two metals are both lead, but they have different chemical compositions. In a sulfuric acid solution, these are lead alloy and lead oxide plates. Alkaline batteries, like lithium batteries, are made by using electrodes and assembling them in a case, though they are not a collection of cells. Instead, each cylinder represents a cell. The cathode, or positive electrode in alkaline batteries, is made of a solution of manganese oxide, graphite, and potassium hydroxide. The electrolyte is potassium hydroxide. All of these are combined in massive containers, and the resulting mixture is granulated and pressed into rings known as preforms. The more preforms that are stacked together, the longer the battery will last. To finish the cathode, the mixture is placed in a nickel-plated steel cylindrical container. containers move along a conveyor belt while performs are inserted from above. They are then bitumen sealed on one end. The separator is inserted in the cathode container to cover the performs before adding the second electrode. It is constructed from layers of paper that have been soaked in the electrolyte potassium hydroxide solution. The anode is then poured into the steel container. This extremely toxic gel is made up of zinc powder, a gel agent, and an electrolyte solution. Finally, a base plate is used to seal the container. A brass pin is attached to it with bitumen. This sticks out of the container and collects current. After connecting the pin and plate, they are pressed into the steel container. The battery's anode end is sealed with plastic, and both ends are sealed with metal caps. The batteries are tested, any defective ones are removed, and stickers denote their type and size are applied to them. And this is how we get a lead-acid battery. This brings us to the end of the video. If you like this video, please consider subscribing and sharing so we can keep bringing more content like this. Also, let us know your thoughts in the comments below. See you next time.